Hi, welcome back to Moose Chemistry, Electron Properties, Pauli Exclusion Principle Introduction. So what is the Pauli Exclusion Principle? All elements have a unique set of 4 quantum numbers, in that no 2 elements can have the exact same set of quantum numbers. Kind of like people and animals, they have their own unique set of DNA, and no 2 animals or life forms have the exact DNA sequencing. It's slightly different from individual to individual. Well, these quantum numbers include the principal quantum number, the angular momentum number, the magnetic quantum number, and the spin quantum number. All right, so the best way to look at this is to do an example. Let's look at the element oxygen. Oxygen is the 8th element on the periodic table, and so therefore it has 8 protons. It would have 8 electrons. And of course, since oxygen has an atomic mass unit of 16, it would also have 8 neutrons. So since it has 8 electrons, we would write the electron configuration as 1s2, 2s2, 2p4. All right, so now let's go ahead and do what we call the orbital notation. So we go up arrow and down arrow, doing Hund's rule. There you go. Up arrow and down arrow. Then 2px, 2py, 2pz, and then back to 2px, like that. So now, the principal quantum number is what period or row is oxygen in? Well, it's in the 2nd period. How do we know that? Because the last valence shell is 2s2, 2p4. And it happens to be in the p block, so the angular momentum number for the p block is 1. And now, when we look at the magnetic number, okay, what does that tell us? Well, okay, so when we do this, we're going to look at our valence electrons here. So we have 2s2 and 2p4. So let's go ahead and put in the valence electrons, or where they belong. So we have 2 electrons here. So we have an electron here and an electron there. Then we have 2px, 2py. These are all up arrows because they're positive. See that? And then, of course, 2pz, positive. And then we come back to 2px. This time it's going to be, of course, a negative or a down arrow, right? So that tells us that oxygen is going to be the following. It's going to be, let's see, -1, 0, 1, -1. So the M value is going to be -1. And this last arrow, if you look at this last arrow in 2px, that last arrow is pointing down. See that? It's pointing down. So what does that mean? That means the spin is going to be 1/2 negative, right? And there you go. There's the spin for that. Now, as you can tell, oxygen has a unique set of quantum numbers that's different from nitrogen, fluorine, or whatever element on the periodic table. No element on the periodic table has that set of quantum numbers. And that's what the Pauli exclusion principle is all about. If you like this video, give us a like and consider subscribing so we can grow this channel. You guys be snarly, and we'll see you back here at Moose Chemistry!